Well folks, it's Sunday and it's going to be Sierra Hotel 1 Tango set Sunday, because we're going to do another great set. And I bought two of these off eBay. I think they're 20 quid for the pair, and one's supposed to light up and the other one not supposed to light up. Two Fidelity 1000s. Both of these have got the extension speaker socket, which is quite a use. You know, when you're getting this low in the range, like last week's G-Col wasn't an extension speaker socket, it makes things very awkward. We've got a bit of a stub of a power lead with no fuse holder, that needs sorting. Is this going to be the one that doesn't light up, or is this the one that is going to light up? So, because it's unknown, I'm going to open it up first. I've already dug out my grate. No, that belongs to yesterday's set. I've already dug out my great test mic. Always remember talking about a brand from Taiwan. I'm not talking about how good the set is. So we'll connect that up to the crocodile clip leads. We'll find out whether this one is the one that lights up or not. Power supply on. We're drawing 80 milliamps. Switch off. Switch on. We're drawing 80 milliamps. So this is the one that doesn't light up. Well, that was a good choice. I said to Mr. Chippy, which do you think is going to be the worst of these two? And they were both about the same, so we just plumped for this one. Now, it could be as silly as a dirty on and off switch. I'll put the soldering iron on because we're going to need that. And we'll run through a tune-up. Tomorrow we're back to customer sets. It's Rotel 220. Okay, well I've not seen that before. So it's had the speaker swapped, and that looks like it's off a York. Right. Certainly doesn't say great on it, but they can fail. So here's the first thing to do. We'll get the test meter out. I think these are negative ground chassis. I will just check. So we'll put one prod on the chassis and the other to the volume control. And we're not getting a voltage, so let's put it to the crocodile clip lead. So it's a floating chassis. I didn't realise that on these. Trouble is, you don't see them every day, even if you see them every week, and certainly I forget, even if you don't. So back to that test again. Right, we've got 13.8 volts. So let's check it. The volume control is on off volume, and we've got 13.8 at one side of the volume control, and on the other side we've also got 13.8 volts. So there's no reason, as far as the volume control is concerned, why we shouldn't have the set lighting up. We're going to dig out the service manual. There's a regulator transistor there, and chances are that either it's failed or the zener that feeds it's failed. So you can see we've got 13.8 volts there. I think it's on the emitter. So we'll take the other case off. I wish these could tell a story and tell you when they last worked. I have this with church organs, you know. When I was doing my apprenticeship, we did an organ, and it last played in 1937, you know. That looks like it's been changed in the past. We're working around here. The only thing that does concern me is why isn't the meter lamp lighting? Because I'm sure that doesn't come off the regulated supply, or has it got a duff meter lamp? But it's in nice condition. It doesn't look to have had a ridiculous amount of use. It's a little bit battered on the front, but inside it's pretty immaculate. Perhaps it failed decades ago. Right, so we'll get the circuit out. So a very faint bit of circuit. So yes, the meter lamp is straight across the full rail voltage. So we've got a diode 11, which is a zener. So just checking once again, we've got it switched on. Yeah, diode 11. Yeah, I mean, the easiest thing to do is to just whip out diode 11. So I think that is what we're going to do. It's those two terminals there. Turn the power supply off, get the solder sucker, and remove that. I can't even remember some weird number. I might have to look that up. I mean, 40 years, how many of these have I actually changed? 3, 4. See whether we can pull that out. Be nice not to break it. We do have a specific diode tester, Z for zeners. Well, there you go. There's our answer. So it's a short circuit. So before I take out the transistor there, chances are that's not faulty and it's just this. So looking at the service manual, diode 11 is what? I'm going to have to... I just can't remember what it is. So YZ085, so you know what, chances are that's an 8.5 volt zener with a number like that. I'm just going to verify that. Right, so I've tried to research that and we can't find, myself or Mr. Chippy can't find any reference to that type of zener diode. Normally you've got an 8 volt rail on a CB radio in this part of the circuit, and so the fact that this number what was it, YZ085, it just sounds like 8.5 volt zener. We've got 8.2 volt zeners in stock without doing any ordering, and I'm absolutely sure that will be absolutely fine. So we will put that in. I've tested the new one just in case. And this is a slightly bigger current. So let's hope it doesn't fail on switch on. Don't think that hole's cleared out very well. What do these cost? About 15p. Right, I'll switch it on now. So we've still got no meter light, but we've got a display. I think the bulb's failed. So now we'll just check what voltage we've got. Throw that away. So we've got 7.79. Yep, I'm sure that's right. So we'll now plug other things in, like the extension speaker to the test instruments and the microphone. Switch picture. I haven't got a camera on the other channel. It was switched on, so maybe it's not plugged in. Just go and find what's happening. Oh, I found the problem alright, so we'll switch picture in picture off. We won't be able to use that for the foreseeable future because the plug's got damaged. So I'm going to have to order a new lead. There's absolutely nothing I can do. We could stop doing repairs and videos. I don't think that's ideal. I'll just read out all the readings. Right, it's going to transmit. But first of all, it'd be handy if I plugged the radio into the test set. So we're hearing S9 and we can see the meter. We would be able to if it had a, so it's we can hear that at 0.3 of a microvolt. So we know the synthesizer is running, we know it's generating frequencies. But what we don't know is we don't seem to have any transmit. So I'm on a 3-watt scale, I've got absolutely nothing happening. So it's probably been on a bad aerial and, you know, this, that and the other. We'll turn the volume down, put my walkie-talkie on, see whether it's generating the frequencies. So pop that on channel 31. We won't, we'll pop it on 20. Testing 1 2, testing 1 2, 1 2, testing 1 2. So the radio is generating the frequencies, but nothing's happening. So chances are, driver of the output transistor, that this resistor here can also fail when it's on a bad aerial. So the easiest thing to do is just check that. So that seems fine. I'll put this remote out of my way because we won't be able to use that for a few days. So what I'm going to do is I've pressed transmit. I'm looking at the ammeter on my power supply. We'll make sure it's tuned up using that technique. Well, I'm not getting anything out of doing that, so I think we'll go for the output transistor and threaten that. So we'll take that one out there. I'm not sure I've even ever swapped one on one of these sets. Before I take it out, I'll test it in situ by just unhooking two of the leads. Just trying to come up with a quick solution. Good, so they don't look to be touching anything. Let's get the transistor tester on there. So center pin, right hand pin, or simply hold, unless it will hook around that. I'll just hold it on. That's fine. I'll test the other one, but we could have gone straight with the RF voltmeter. I'll just unhook two again. So that works as well. So something else is wrong. Just make sure it hasn't suddenly started miraculously working. Right, we'll get the RF voltmeter out. Certainly nothing there. So let's have a look. Have we got anything on that coil? Seems not. What about the previous coil? Loads. That's interesting, isn't it? I'm just going to go for dry joints first. But you know what? Back in the day when these were new out, if you pushed the thumb screw correctly as stated in the instruction book, the screw was so long it pushed over L6, but it doesn't look damaged. So we'll just go for the dry joints first. But you know, it's if the regulator's failed, which it has, a zener, you wouldn't expect it to be. You could expect the output to not work because of a duff transistor, but I'm not really expecting something in this stage to be faulty. Let's try that. Nope. Let's see what I can find off camera. Right, folks, we've come to a point. So, transistor under test, no component detected. Right, put that on one side, put that to throw away. So, on the circuit diagram, I've checked that we've got the rail voltages through to the output transistor. This is such a faint diagram. So our output transistor, which is there, isn't it? Yeah, I think it's 2078. And then we've got the driver transistor. So that's the output transistor, that's the driver transistor. So I've got nothing at this coil, but if you heard, remember it was transmitting into our radio, so it has to be working to here for that to happen. So those coils are there. You've got 3 stages of transistor amplification. So if I started at that one, that is the sensible course of action. So that's where I've started. So turning the set over, we come to this part here. We have taken the transistor out, and I've put my big hefty RF voltmeter onto there. We've got an input, we've got no output. We've got the voltage there, so it should work. And as you see, it says no component detected. So I'm going to tell you what, I'm going to put this away. I think this set has been 24 volted. Here's the clues. Voltage regulator short circuit. Meter lamp failed. I don't get meter lamps failed on Fidelity 1000s. People aren't excited enough to use them 24/7. So, and a transmitter transistor failed in a part of the circuit. I've never known that happen. So what we've got here is our mystery benefactor Alan sent this very scrap GT868 for spares. It was once an elf tone, which is a shame. But it was once an elf tone, and it's got a lot of parts missing. The filter, there's a filter gone there. I could have welded some bit of chassis in there had it been complete, but the notorious L6 has gone. That's the one where you end up pushing it over if you put the screws in fully. So have we got the transistor on this one? Yes, we have. There we are. So the transistor's still there. So I'm going to unsolder that, and I'll... Oh yeah, this really had the... yeah. So I'll just pause the video while I do that. Right, so this part tests absolutely fine. NPN bipolar transistor. So we'll get that soldered in. I do have these new, but I may as well recover it off a scrap chassis. Just make sure the spacing's right. So by the time I've wrenched it out, yep. Now, surgical scissors we use to put these in easily are in the organ workshop, so I'll just see if I can do it with the pliers. That feels like it's gone in. Just make sure they are all in. I think we'll just push a bit more of that through. Good. Right, we'll switch it back on and see what happens. Whee, we've got transmit now. Sorry we can't see any of that with that cable being broken. So we're now greeted with, I think we're on low power, we're greeted with quite a low amount of, oh no, we're on high power, but it may be out of tune because of me twiddling it. So at the moment we're virtually spot on frequency. It's 27.79120. I'm not even going to bother opening this can up because it's so close. It's 121 actually. Let's have a look at the transmit power. We're on the 3 watt scale and it is doing 0.6 of a watt. Zero 0.65, 0.67, 1.2 watts. Remember, anything over 1.7 is acceptable. 1.4 watts, 2.2 watts. 2.8 watts. So we need the suitable tool for the hex one. Now we're beyond the 3 watts of this range I'm on, so I've switched my range to 30 watts and we're at 3.4. So just need to backtrack on that one, just make sure it's still peak, because they are interactive to some extent. And then we just check that one as well. Let's see if we can do it with that tool. Well, you know what, I don't often see this. This is doing 4.2 watts. I'm going to have to turn it down. I've only once seen a GT8 488588868. I've only seen one do 4 watts before. Wow. There we are. That's impressive. Now on low power, I'm going to have to start filling a sheet in for this. On low power, it's not adjustable. You get what you're given. It's 170 milliwatts, so it's pretty lousy. Right, so I'm just going to pause the video. We'll get a sheet out. Right, back to the land of the recording. So let's just have a look at this on other channels. So on channel 40, we've got 3.5 watts. Maybe to balance that better. I may be able to balance that better. Let's see where it is on channel 1. Oh, I don't know. Tell you what, we'll pop that up to 4.0 something. Just like that. So now .6. So that's 4.05. 3.6. At the other end, 3.7. Transmit current on channel 20. It's still only 918 milliamps. That's efficient. That's flawed because I'm not going to write that down because there isn't a meter lamp in yet. Deviation. Bearing in mind this test set, I need to check the one with the one behind it. Wallow. So it's 3.2 kilohertz on there. So sometimes it reads right, sometimes it doesn't, but we'll adjust it assuming it doesn't. Sorry, assuming it is right. Wallow. There's where we are, a peak of 2.5. So I will verify that with the test set behind me. Frequency is 2779121, 2779121. Not going to alter that. Not going to touch that. So the meter is reading what? Oh, here we go. How do we read this in the dark? I've got a torch here. I'll just shine this through. Supposed to be in the centre of the red zone. Which it now is. So that's that done. So that's covered all of transmit. But I'm sure you can see my logic. The fact the meter lamp's gone, the zener's gone in the regulator, some random transistor's gone in the transmitter. I just think it's been 24 volted. Oh, it doesn't matter, it's a Fidelity 1000, but it's an outstanding one because it does 4 watts. Okay, so no, I think we've covered everything. Let's go to receive, and now we'll be able to see what this did before. So I'll just make sure we're on frequency. Okay, I can't put picture-in-picture on, obviously, for the reason we all know, that the link cable's knackered. So you have to take my word for it. But at the moment, this is doing 0.45 for 12 dBs. It's doing 0.4 for 10 dB, and if it will do, it will. It does it at 0.8. I'm not sure we're going to get much better out of that because they're a sensitive set, which is the downfall. So look where the squelch is, a full squelch. So 1, 3, 10, 30, 100 is exactly where I want it to be, 100 microvolts. And at the sensitive end, we'll just park the signal generator at 0.3 of a microvolt, set threshold on the radio, and see when it comes in. .55. They're really nice figures. Let's look at S9. It should be showing on the meter, and it is. It needs to come down a bit. I'll get a figure. So at the moment, S9 is 590 microvolts. So it's a bit generous. Good. Right, we'll go through the tune-up. So I'm going to start with the detector. These are quite pesky to set up, as you know. So the two detector coils here. And I have to have exactly the right tool for these. The main one is this. And that was spot on. And the not main one, because it's normally done with the sweep generator. I've shown you that technique. But since developing the cyanide technique, we've had better results. Right, so that's got the detector somewhere near. Now we'll do the front end. Turn the squelch down. So I've got the cyanide meter on. We've moved it to about 4 dB, and I'm looking to obviously get that better. That was exactly spot on. Actually a slight improvement on that one. That was spot on. Now we'll move on to these IF ones. Put a bigger signal on. And take that off again. Check this other detector one. Bigger signal. Double check the main detector one. Right, we have it. So there is a tiny improvement. So let's see what it is. For 12 dB, we now have 0.4. 12 for 10 dB. We've got 0.35, and any improvement on 20, 0.75. Yeah. Hopefully this stays the same. Squelch to full. 1, 3, 10, 30, 100 microvolts. Yep, it's exactly where we wanted it to be. And on the threshold, set on the radio, signal generator on, 0.45, so it's even better. So that's got good hysteresis, so it tracks the squelch well. Right, S9. This could be the best Fidelity 1000 ever. So we need to do the S meter. Sure it's that one without looking at the manual. That's as low as I can get it. It's just on the plus of plus 30. So I'm going to get an exact reading, to be fair. Actually, no, it wasn't 59, was it? It was 59 microvolts. It's now what? 30. It's no, I can't get any difference. It's 59 microvolts. It's a bit sensitive. There we go. So I need to put a meter lamp in this. So we've got one there. So I'll pause the video. I've done the meter lamp. I put the bottom case loosely on. We turn to this wrong speaker and it looks like it's open circuit. It is. Well, these radios are only 1.5 watts output, so unbelievable. Unbelievable. Right, we'll get a new speaker in and add that to the list of expenses. There's nothing really under a £5 these days for speakers. The ones we'd like to use are 16 something or other. Good. I'll be quite interested to see the one that did light up. It would be funny if it had more wrong with it than the one that didn't light up. So we'll get this unscrewed and get a new speaker in there. I'll do away with those clips, which won't be suitable anyway. I think we'll probably solder these onto the tags, or we're going to end up with no wire. Okay, so that's another speaker put in it. Type new. And hopefully it works. So that just remains to put some case screws in it. So I'm looking forward to doing the on-the-air test. We're only about an hour away from doing that, because with the full 4-watt output, which you don't normally get, I think this is going to work really well. I don't think we're going to get it on the 5-mile point when we go to low power, because it's only doing 170 milliwatts. So when I look at the next one in a few weeks' time, I won't do another Fidelity 1000 next week. We'll do another set with the same kind of chassis. Got one that Alan kindly sent us. I think it's another 858. In fact, I noticed the two 858s up on eBay right now for $49.99 the pair. Yeah, right. And then I just want one more screw. That type, which is kicking around on the bench, isn't the right type. So the two of the screws I took out of this are too long. Now there we are, we've got a new screw there. Right, I'll switch the soldering iron off. You know what I've not done? I've not checked the deviation with the test equipment behind me. So I'll just do that. I'll plug it into the other test set. I'm going to end up taking those screws out again, aren't I? Wow, no, it's spot on. Excellent. So my normal test set was not playing silly whatsits. Right, we'll put it on the aerial. So it's what, 6:30? One and a Roger.
You speak French?
Negative. No, just full of illegal foreign muck. You know, SSB is not permitted in any country in the world on these frequencies. So there you are. They, you know, nothing's going to change, is it? Right, we will. Roger Breaker. Roger Breaker. No, you can't hear me, and I know I'm getting out 35 miles, so in that direction. So it just goes to show what power people are running. So there we are, Fidelity 1000, out of a batch of 2 I bought off eBay, and this is supposed to be the worst one of the 2. I think it's been 24 volted, so we've ended up with a lamp, a zener diode, a transistor, and a speaker. Thank you for watching.